Hi everyone, I'm Felix. I'm from Germany, so I do really like rules. Don't tell anyone. This is my Twitter handle and my GitHub handle. And I'm here to talk about type-safe web workers. Not those web workers, they work on webs too, but different ones. We already got a really great introduction to web workers at the last event. I wasn't here, but I saw it. It's on YouTube. I highly recommend you watch it. If you haven't, the TLDR is web workers allow you to run truly parallel code, which, JavaScript is single-threaded. You can pass messages to workers, and you can type those messages with interfaces, and you can handle the messages with a switch statement. So this talk is kind of like a level up from this. At Sourcegraph, where I work, we have a website where you can, where you can view code, amongst other things. Enhance. And you can extend this UI yourself. So, for example, you can install a CodeCoff extension that adds these awesome little line decorations. You can write an extension that adds these hovers here, which we have these code intelligence hovers for TypeScript and many other languages by default. But all that goes through extensions, and those extensions run in a web worker. There are a lot of extensions in the extension marketplace. And they also run on GitHub and many other codos like GitHub, Bitbucket Server, all through the same extension API. So we run them in the web worker mostly for isolation reasons, so they can't just mess with our DOM, and also for performance. So whatever they do, they will never make the UI thread block and cause ugly UI glitches. This poses a challenge though. So they run in this web worker, and they have a pretty big API at their disposal. Pretty powerful, big size, and you might think or be able to tell that a switch statement doesn't scale to handle all these messages. So the problem here really is, okay, how can we have, when we have all these messages for all these different APIs, how can we expose those to the extension running in the web worker without having a giant switch statement, without writing interfaces for every single of these messages, having one message per different method call? The first very simple solution would be, okay, instead of having one interface for every method call that the API allows, you just have one message, and that message just contains the method you want to call. So the web worker might just call post message, pass in an ID so the responder can actually tie it back to the original request. Say, I want to call set decoration, like with the CodeCoff example, and I want to have decorations on example.ts in line 3, and it should be red. And on the main thread side, we can expose and we can have an object that just defines all these methods instead of a giant switch statement. And we can handle messages from the web worker and just call the method that was passed on that object and pass all the parameters that were passed. And then once we have the result, we can post that back in another message. The problem is that in the extension, you don't want to call post message. You want to have a nice API like this, where you actually call a function. But this function that you're calling, this method, is not actually in the extension web worker. It's in the main thread. So there's a feature in ES6 was introduced that we can use to make this better. Instead of having to write each of these methods, like set decorations and the 100 others you were seeing, and filling them out with a post message call. We can use an Es6 proxy, which, if you haven't used them, they basically allow you to handle any property access, any function call, anything like that with one function that traps all these things, and can delegate it to just like send a post message, get the result, and return that. So from your perspective as an extension author, it looks like you're calling set decoration. Really, that all goes through this one proxy get handler that delegates all of that to the main thread. That saves us a lot of code already, because we don't have to like define every single method with a post message, but we only have to do that once. And this is kind of what we started out with. Oh, by the way, this extension API is very much inspired by the VS Code extension API. They do that in a very similar way. They don't do something which I'm going to get to soon. The problem is that many APIs don't actually look like this, where you just call a static function set decoration and pass some like static parameters. But many functions and APIs actually look more like this. You want to register some object, a mutable object, that contains a function, and then the main thread needs to get notified, hey, this is now registered. And for example, with the hover provider, that is the thing that provides you these little hover tooltips here. Whenever I hover something over something, it then wants to call that provider in the web worker, get the result, and show that to the user. This is tricky because you can't just pass this function to a post message call, because you cannot clone, serialize a function. So despite having that awesome proxy code that makes calling the function so much easier, you still actually end up having to write a lot of wire code that actually takes the hover provider, assigns it like an ID handle, then just gives the ID handle to the main thread, because you can serialize an ID. And then when the main thread wants to call it, it calls back into the extension host in the web worker and says, okay, now please call this hover provider with ID 3. And we ended up having to write this kind of code for almost every single piece of the API. It's still a lot of boilerplate, a lot of repetition. It's a lot of noise when you try to read and understand the code. It means that adding new API is a lot more effort and takes longer, and you're really like dreading the work. You don't want to add new APIs, which is not what you want to incentivize your engineers. But also, whenever you see something that kind of, you squint your eyes and it basically always looks the same, when the code is always kind of repetitive or feels repetitive when you're writing it, that usually means there's an opportunity for abstraction. So I thought, okay, how can we somehow abstract this like ID assigning mechanism? I pass in an object, assign it an ID, and then the other side can get a mutable reference to that and do stuff on it. Could we maybe move all that ID assigning logic just to this proxy transport layer and just use like globally unique IDs for every object? That was my idea when I investigated it, and as with many ideas that you have, it turns out somebody already had that idea before me. So there's this really awesome library on NPM called Comlink that basically does exactly that. You can pass it any function in your web worker or in the main thread, it works both ways, that you define. And then from the other side, you can get a proxy for that exposed object and call any function on it, get any property on it, and through the Es6 proxy, like it completely transparently behind the scenes all handles that for you. The only difference is that since message passing is asynchronous, all the methods now return a promise, and all the properties are also wrapped in a promise. So well, you can see here it's just like number and returns void. Here you need to pass it an interface that where the value is a promise of the number and the method returns a promise. So right now this is still kind of like our simple proxy example. But where this really shines is when you want to pass in these mutable object references of functions. So like, with the register hover provider example, you can wrap that hover provider that I was passing in comlink.proxy, and that tells Comlink, okay, this value I'm passing to the function, please also proxy that. And instead of having to do all this like ID dance manually, Comlink will do all of that behind the scenes. So here, the main thread exposes this API of register hover provider. The worker can call that to register a hover provider, which is then passed in here as the p parameter assigned to the provider variable. And this is just like a dummy hover handler, but you get the idea. It can just call that hover provider asynchronously, get a result, and didn't have to do any boilerplate code. That's pretty neat. There's just one problem left, and that is, how the heck do you type that? If you remember the first example I had here, you still need to provide this interface, because when I tried out the library, it had no way to know that the object you're exposing, like everything now returns a promise. So with our gigantic API, we still had a lot of code duplication because we still had to define all the interfaces basically twice. We saved the implementation, but we still had to define all the interfaces. So the challenge was, can we define some kind of type that, given the original type where everything is synchronous, gives us the type where everything is proxied. So in essence, simplified, it needs to change all properties to a promise and all methods to return a promise. This is the part of the talk where we start to flex the TypeScript types muscle. So in TypeScript, iterating over every single property of an object is possible with map types, which is relatively recent, although I think not that recent anymore. So given any object type, we can go over any property in that object type and transform that the way we want. And for each of these properties, we then want to check, is it a method? If it is a method, we want to change the return type to return a promise. And we can tell TypeScript to tell us the type of the arguments and the return types with the infer keyword. We keep the same arguments, only change the return type. Or if it's not a method, but just a regular property, we just wrap it in a promise. And this looks pretty simple, actually. But there are several things missing here that would make this not fully work. First of all, if you have a function that already returns a promise, you would get a promise of a promise, which actually is not possible in JavaScript because it's like automatically unboxed. So we need another helper that that only wraps a value in a promise if it's not already a promise. Second, functions can have properties too. So we want to consider those properties too. If we have a method with properties, those can be proxied too, and we want to apply this proxied object type to those properties of the functions too, as well as change the function call signature. So we're introducing this new type, proxy function, that is an intersection type of the proxied object and what we did for functions. Now, so far, we're actually not handling this really awesome comlink.proxy wrapper. That was really the interesting part about the library. And you might wonder, how does that even actually work? And it's actually pretty simple. It just, whatever you pass the comlink.proxy function, it monkey patches a symbol on that object that says basically, hey, Comlink, please proxy this. And then it can read that in the layer where it sends that over to the web worker. And in recent TypeScript versions, we can also check for that symbol. So we can define that symbol in the type system. We can define an interface that has this symbol as a property with true. And then with conditional types, the ternary type syntax, we can react to the symbol being present or not. So now types, we're not done yet. Sorry. There's another problem with this, which I didn't even realize at first, but once I tried it out, we currently just take the arguments directly and not touch them. However, that is not correct, because if you pass a function into the proxy, then from the perspective of that method, that function is now async. But from the side where you're passing it, it is synchronous. So actually, from the signature standpoint, you need to do the inverse operation. So you need to unpromisify everything. So for each of these types, we now need to define the inverse too. So given a proxified value, what is the unproxified, the original type? That looks like this. This is an addition. The rest didn't fit on the slide anymore. And then we can extend the proxy function type to also iterate over the arguments in the tuple type and apply that reverse. This is the end result. But you don't have to deal with that because I wrote that already. So all of this just so that you, when you're in your editor, you can just call any function from a web worker and it's like completely automatically, everything is suddenly a promise or not where you don't want it to. And you can pass functions and they're the reverse and all that stuff. I don't even understand it anymore. And I think this opens up a lot of great opportunities. Comlink doesn't just work with web workers. The same protocol can basically be used over any stream that supports strings. So that is WebSockets, that is browser extension port objects. That is Node.js worker threads and just std in, std out communication. I wouldn't necessarily recommend doing it over the network because it's not built for that and it can't do stuff like version negotiation or anything like that. You need to be running the exact same version. But anything that's like one isolated application, I think it's really important if we bring down the barrier to parallelization. I think it's going to be used a lot more, and that means we can maybe drastically improve performance of many, many use cases. Like, how awesome would it be if, I don't know, Webpack could easily hand off compilation of every single file into like a thread pool. We could become very close to something like Go routines, but in JavaScript. Yeah, that is my talk. Thank you for listening. Again, this is my Twitter and GitHub handle, and if you want to find out more about Sourcegraph or push TypeScript to the limits together with me, you can go to sourcegraph.com. We have open positions.
Yes.
So
Are these published as the @type/comlink package, or is this private to Sourcegraph, or?
The types are integrated into Comlink.
Into the
They ship with
bundle.
Comlink.
Okay.
I must admit, I did a PR for these types. At the same time, the author was also working on like a major breaking change v4 of the library. So he closed the PR eventually and said, I think this should be fixed now with v4. Let me know if it doesn't. And I didn't get around to upgrading to v4 yet. But mostly, you know, this is a proof of concept. We also have this published as a fork. And I mean, eventually I wanna get this into Comlink again. Yes.
So I was just wondering, did you have any issues with overloads, or doesn't your API have overloads?
This is a problem. So overloads are a problem because map types cannot go over overloads. And I've commented on some issues in the TypeScript repo because that is an annoyance for exactly this use case.
You can extract overloads from my experiment, but it's rather clunky, so yeah.
Yeah. What you also can do is you can merge overloads into one with like conditional types and tuple types, but that requires to change the library, which you usually can't do. Worst case, you need to write a little like adapter function to wrap your value first into something that the types can understand. Yes. Oh, sorry.
Oh, sorry. You can go first. Okay. Thank you. So just another question: did you have issues with errors and these complicated types?
Did I have issues with? No, I wrote these in one go. There was not a single.
No. What I do is called type errors. I mean, whenever I use complicated types, I usually end up with these unintelligible errors that usually have issues with.
Yeah, they can sometimes be a bit confusing.
It'll be less bad in 3.7.
I think it's kind of the nature of these types. I'm not sure if the TypeScript team can improve much about this. But yeah, I think for the most part, this has worked mostly fine.
Thanks.
Yes.
Do you have any, or I haven't, it's been a while since I've taken a look at the GitHub repo for Comlink. I've played around with it before in the past, but I ran into some issues in terms of integrating it with existing projects, and it really just came down to how Webpack was working with Comlink, or just web workers in general, where I'm referencing a separate JavaScript file in which that's my separate thread, and Webpack generally is just like, well, I don't know how to handle that without some sort of loader when I try to import and reference, because like if you were to work with web workers plain, right, with say any sort of JavaScript document, you would reference the file path to a separate JavaScript file, and the browser would just say, okay, throw that on a separate thread, and then you can do your messaging. But with Webpack, it's just like, I don't know what's going on here. So do you have any sort of like sample repos that I can take a look at where you have Webpack configured, or?
Yeah, I mean, we use this in the Sourcegraph codebase. The entirety of Sourcegraph is open source. So you can look at github.com/sourcegraph/sourcegraph. And you could use Sourcegraph to search for worker loader, I think. So I think we use the Webpack worker loader. And with that, I think just import a file, and the import value you get is like a worker object. And that works with Comlink, because you can pass that worker object to Comlink. You can also trigger it, like, because you need to specify, right? Like, this import should be a worker. You can use this like Webpack syntax, where at the end of the import, you just say worker loader or something, and then Webpack knows it should use that loader. I think that's how we do it, but I think our repo would be a great way to find a working sample in like a real world application.
I also would plug Parcel Bundler real fast because it does web workers out of the box. You don't have to configure it.
Nice.
That's very simple.
Yes.
Since you mentioned Sourcegraph, I haven't used it. Forgive me for my ignorance, but I assume it's some static analysis that does.
Mhm.
You also mentioned proxies in the same talk. So
Proxies?
Proxies.
Yeah.
Is it like, does that break static analysis? Like, do you use dog food, your own tool with proxies? Is that a problem? Like, very dynamic dispatch for proxies can ruin static analysis. Does it work? Does it just bail out?
Yeah, we dog food our own tooling. Also, our TypeScript code intelligence tooling is actually like calling into TS server under the hood. So it's the same TypeScript code intelligence that you get in your editor. The great thing about TypeScript is that you can just write an interface that describes your API and then say, okay, this is my proxy and it implements this interface. And then you get code intelligence and static analysis and everything on that. And everything can be implemented dynamically through that proxy. And with the types I was showing, you don't even need to define these interfaces, but you could just like say, const my object, that's my object, and then you use like type of my object and get all the other side where everything is async inferred. So yeah, that works very well. You don't get to see the proxy under the hood at all. Any more questions?
Is there a dark mode?
There is a dark mode, and we do respect the OS theme. Thank you. I built that. All right.
Thank you.